Today we're going to talk about BondEnergy in the Chapter 8 and 9 AP Chemistry packet on page 5. We're going to start off with talking about methane. Methane is CH4. This is what comes out of your stove if you have a blue flame at home. It's also what we use in the classroom when we use our Bunsen burners. And it's a gas that is flammable, and that's why we use it, because it burns and produces a lot of energy. And how do we get that energy? We break the bonds between the C and the H, and those bonds get broken and release energy, as well as the oxygen's bonds when it reacts. And it will form carbon dioxide and water as well. But it releases more energy, and so it's exothermic. Let's take a quick example. Let's suppose we're back to our bread and cheese sandwiches. So we have 2 breads plus 1 cheese gives 1 sandwich. And let's say the bread costs us 10 cents a slice, but there are 2 breads, and the cheese costs us 25 cents a slice, and we sell the sandwiches for $1. And I ask you, are we making money or losing money? The answer is we're making money because we're selling the sandwiches for $1, but the total cost is 45 cents for the whole sandwich, not including labor, of course, but 45 cents. So it costs us 45 cents, but we're selling it for $1. So you would do $1 minus 45 cents, and that's going to give you positive 55 cents. Positive. So that means we're making money. We're taking in money. And that's because the products have more stored energy than the reactants. Okay, the products have more stored energy than the reactants. But let's suppose that there was a guy down the street who was trying to take our business away from us, and he still has to go buy bread for 10 cents, and he still has to go buy cheese for 25 cents, but he decides he's going to try to sell his sandwiches for 40 cents. So he's selling it for 40 cents. But it costs him 45 cents to make the sandwich. So every time he sells a sandwich, he's losing a nickel. So his delta or change is negative 0.05. He's losing a nickel every time. Okay, so he's exothermic. He's giving away heat because he's giving away money. But in our example, there's more stored energy in the reactants than the products, in his case. So therefore, he's giving away energy every time he does a reaction. That's exactly what happens with methane when it burns. Here is the equation for methane burning. And when it burns, there's going to be more stored energy in the reactants than the products. And so what's going to happen is you're going to release energy. So what we need to do is find the amount of energy in each of these bonds. So the first thing you're going to need to do is draw the Lewis structure for each of these, which now you're an expert on that. So we'll quickly draw the CH4. Looks like this. Oxygen has a double bond if you take the time to figure that out. Carbon dioxide also has 2 double bonds, as we saw from our practice earlier. And water, of course, has single bonds with the H and the O. But remember that there are 2 waters and 2 oxygens. Okay, because you have 2 here and 2 here. That's important, and we'll see how that plays into our problem here. So what we need to do is we need to look up how much energy is stored in each of these bonds, and you have this chart, which of course we would give you if we were to give you this on a test or quiz. So we're first going to look up the CH bond. The CH bond is right here, and it's 413 kilojoules. So look in our structure, and we have 413, okay, but that's for each of those bonds, and that's going to be times 4 because we have 4 of them, 1, 2, 3, 4. Then we're going to look for the O double bond, and that bond right here, O double, is going to be, on this part of it, 495 right there. 495. So we're going to have 495 kilojoules for that one, but remember, there are 2 of them in the equation, so you have to put a 2 in front of there. Okay, now we're going to look up the CO2. And CO2, you have to be careful. You have to use this one over here for the CO double bond. There's another one that's up top right here. This is not the right one because it says for CO2, you have to use this. So it's 799, but again, you do have two of them in the molecule, so you have to put a 2 there. And then lastly, we're going to look at the H2O, and the H2O has an HO single bond, and that is going to be right over here, and that's 467. So we have 467. Now remember, there are two of them in the molecule, but there are also two molecules, so you have to do that times 2 times 467. Okay, so you're going to whip out your calculator. You're going to figure out all of the totals for each side. The total for this is 2642 kilojoules. The total for this side is 3466 kilojoules. And so we're going to realize that we're going to release energy. We're going to release energy because this has more stored energy. So when it has more stored energy, there's going to be, in the bonds, it will be an exothermic reaction. And so the way you do it is reactants minus products. Now, unfortunately, I think I kind of said that backwards up top here. That's going to come into play when we do delta H in a different way. So just do it this way. Reactants minus products, okay? It's always reactants minus products, delta H equals that when it's bond energy. So just remember, bond energy, delta H, is reactants minus products. So when you take this minus this, you're going to get negative 824 kilojoules per mole, which makes sense that this is exothermic. It's exothermic because it releases heat.